Capturing with Wireshark. Wireshark has some amazing options for capturing data, and sometimes we're not going to take advantage of those features unless we know that they exist. In this video, we're going to take a look at some of those options and how to use them. Let's begin. Have you ever been to a rodeo? I remember going to a rodeo once, and the rodeo clown in the center of the arena was looking in the dirt for something, and the announcer said, "Hey, what are you looking for?" And the clown said, "I lost $1 and I'm looking for it." And the announcer says, "Where did you lose it?" He said, "Back in the stables." And the announcer says, "Well, why in the heck are you looking out here in the arena if you lost it back in the stables?" And the clown said, "It's simple. It's because the light's a lot better out here." So in our network with Wireshark, if this user right here is going out to the internet and having significant latency or delay or other problems, we probably don't want to start capturing right here on this segment because we're not going to capture the data. We need to make sure we understand what our options are to control the capture, to make sure we are looking in the right place for the traffic that we need to analyze. So what do we have as options regarding collecting the data that we're going to go ahead and analyze? Somebody once said location is a big factor in real estate, and I do believe that happens to be true. In Wireshark, location is also very important. If we are trying to find out what's going on for this customer right here, we could just install Wireshark right on that computer and start capturing the data. The packets that go in or out of that interface, we could simply capture that so we could look at it. That is not, however, our only option is to capture data right here on this computer. We could also do port mirroring. Now it's called different terms with different vendors, but effectively what we could do is if this port is gig 0/2, for example, that this customer is connected to, we could take our Wireshark machine. I'll go ahead and put a big W there. Wireshark. We could take our Wireshark computer, which could be the Macintosh, the Linux, the Windows, some computer running Wireshark, and let's say we plug it into port gig 0/24 right there. So the customer's on gig 02, we're on gig 0/24, and all we do is we tell the switch, "Hey, dear Mr. Switch, please send me a copy of all the frames, all the data that you see either going out of, that's egress, or into, that's ingress, regarding gig 0/2, and mirror that or copy it over to gig 0/24. Then we can have Wireshark just sitting there collecting that data and analyzing it. So we don't have to run any kind of collection software on this PC. We can do it on a switch that supports this port mirroring function. Now, in many environments, perhaps you're not authorized at the switch to go ahead and start changing the configuration. Or maybe you have a switch that doesn't support that mirroring function. What else can we do? We can also use something called a tap. Here's an example of very fun Ethernet tap. It's got 4 connectors on it. It comes as a kit, and you can actually buy this kit for like under $20 and put it together yourself. You can also buy it assembled if you want to as well. But here is effectively how it works. We take the client connection. This is the network interface card, and this is gig 0/2, for example. We take the cable from the NIC and we put it, for example, in J2. We take the cable from the switch, we put it into connection J1, which is right here. So effectively, this tap is sitting in the middle, physically, between the PC and the actual switch. Any traffic that goes through this tap can also be seen by any devices that are plugged into here. So we'll put a big W on them for Wireshark, and now this Wireshark machine plugged into either J4, which is right here, or J3, can now effectively eavesdrop on everything that's happening, and as a result, Wireshark can start to collect all that data into a new capture. Now, taps are going to vary in expense and functionality. For example, I believe the maximum throughput on this is 100 megabits per second. So what happens if you put it in line with a customer who's currently at gigabit? Hopefully, auto negotiation is on at the switch and at the network interface card, and they can both negotiate down to 100 megabits per second. There are more expensive and more elaborate taps that can go greater speeds, but of course, they're going to cost more as well. Another option that we have are captures that are created by other devices or other software. For example, if somebody has an intrusion prevention system in their network, it's very likely that system has the ability to capture packets. Most firewalls have the ability to capture packets, and Wireshark has the ability to read most of those types of captures natively. So you can just open up the file with Wireshark and you're off to the races. What I'd like to do with you right now is take just a moment to give you an example of setting up port mirroring on a switch. And for this example, let's say the customer is at gig 0/2. We have the Wireshark PC that's plugged into gig 0/24. And for this demonstration, I'm going to be using a Cisco 3560 multi-layer switch. And I'll walk you through those commands to mirror all the data in and out of gig 0/2 over to gig 0/24. So on the switch, it's pretty straightforward. We're going to go into configuration mode with config T, and we're going to say monitor session 1. We're starting a new port mirroring session. We want to say the source is going to be gig 0/2, both traffic going into and out of that port, and we want the destination for this monitor session to be gig 0/24. It really is that easy. If we want to verify the details, we can do a show monitor, and it shows that our source port is gig 0/2. The destination port is gig 0/24. And we're not restricted to just collecting data on ports. If we wanted to say, you know what, I want to collect the data for the entire VLAN and replicate that to a destination port, that is also an option. When we have local port mirroring, for example, we're doing gig 0/2 and we're sending it off to gig 0/24 on a local device. In Cisco, they call that SPAN, Switched Port Analyzer, a local SPAN. And if we have more than one switch involved where we're capturing data on switch 1 and we're replicating that over to switch 2 and then copying out to the destination port here, that's called remote SPAN. Another challenge comes up is when we have our Wireshark machine and it's got multiple interfaces. Let's say I have interface 1, 2, 3, 4, and we're listening in. We want to make sure that we tell Wireshark the correct interface to use to collect that data. And we also have the option of setting up filters. For example, we can say, you know what, if we're connected to this port right here, gig 0/24, and it's set up with mirroring, like we just did, we can actually set up filters, capture filters, and say, you know, Mr. Wireshark, even though we're sending you copies of all the data that are going in and out of gig 0/2, I don't want you to have to process all of that data. Go ahead and filter out and only select the data that I tell you to. For example, maybe only certain types of protocols or certain addresses, if they're present, are going to make it into the capture. Another really important thing to work with inside of Wireshark are files. Now you might be saying, well, Keith, of course Wireshark has capture files. It sees the data, it collects it, puts it into a trace. They call these traces capture files. What's the big deal? Let me share with you what the big deal could be. Let's say with authorization that you've plugged into a customer's network and they're experiencing some type of a problem. Let's say we plugged in right here. And let's furthermore say that they have some kind of a routing loop where R1 sends packets this way and R2 sends packets this way. Maybe not for all traffic, but maybe for some types of traffic. They're doing policy-based routing or something else. Well, if packets are looping like this, the TTL is going to be reduced by 1 every time it hits a router. So when the packet goes in, it might go back and forth a couple hundred times before one of those routers finally kills it. And if a PC is sending in thousands of packets, and each of them are looping hundreds of times, that's a lot of traffic. And if it just goes on and on and on, it's very possible that Wireshark, without giving some controls, could fill up your whole hard drive. And that would not be a good idea. In reality, if we get much more than 100 megabytes per file, it just becomes unwieldy and more difficult to work with those size of files inside of Wireshark. So the good news is that you and I, by just setting a couple really easy capture options, we can absolutely control the maximum file size. And if we need to capture, for example, for 24 hours, we can do that. Or if we need to say, you know what, I just want to do a rotating capture. I want to capture the last 5 or 6 hours of data, but just beyond that, I just want to do first in, first out. We can do that as well. Let me share with you how we can control those capture options right now. So in Wireshark, these options right up here, we have the interface list, the capture options, and the start option for starting a capture. Those 3 options happen to be right here on the start page as well. Let's go ahead and start with the top left and take a look at the interfaces that are available to us for capturing. This is a fantastic way to help identify, if you have lots of interfaces, which of your interfaces are the most busy, which ones have packets moving. If we have an IPv6 address, that is the address that will show. That gives us a good indicator of which interface we're talking about. Also, if we have IPv6 addresses as well, a dual stack computer with IPv4 and IPv6 on the same interface, it'll show the IPv6 address here. With a click, we can change that over to IPv4 just to verify which interface we're talking about. Another really cool feature is that if we go to details of these interfaces, it can provide additional information for us as well, including the detail of whether or not this interface is going to support wireless. And that's a really good indicator if we have an interface that's on a wireless network that we could also use to gather additional information in a capture on a wireless network. So we'll go ahead and close that. I also want to close this. The next icon is our capture options. Now with our capture options, if we wanted to, we could capture on multiple interfaces at the same time. In this example though, let's go ahead and choose this interface right here to go ahead and capture on. And let's say, for example, we wanted to collect data for quite a period of time. However, we wanted to make sure that a capture file never got larger than 100 megabytes. How would we do that? The answer is we're going to go ahead and use multiple files. We're going to click this option here, say I want to use multiple files, and we can go ahead and browse for where we want to put those files. I'm going to go ahead and browse to a special folder I created just for keeping multiple capture files. And let's call this, I'm going to call it multiple.pcap. NG. So that's the file names, the base of the file name that I want to use. We'll click on OK. We'll go back to our capture options. So put right here the file name I want to be using, and check this out. Let's say we wanted to make sure we never got past 100 megabytes. What we could do right here is simply say, okay, I want to create a new file every 100 megabytes, or let's even go down. Let's go to 10 megabytes. So once we hit 10 megabytes, it'll automatically create a new file for us. The first one will be multiple 1, then multiple 2, and multiple 3. And that will go on and on until we do something to stop that capture. We can also specify that, you know what, I want it to reach either 10 megabytes or every 30 seconds. Now this is just as an example. We have seconds, minutes, hours, or days. And so what this says is if 10 megabytes is hit, if the capture gets that big, we'll automatically go to the next file. Or if 30 seconds goes by. So whichever of those two hits first will cause a new file to be generated. If we wanted to specify that, okay, after 10 files, go ahead and stop the capture, we can use this option right here. Or we also have this really cool option called a ring buffer. Check this one out. With the ring buffer, we can say, you know what? I want to go ahead and save the last 3 files. And what that will do is every time we hit a new file, which is either 10 megabytes or 30 seconds, whichever comes first, and we get a new file, it will only keep the last 3 of those captures. So that way it'll continue to capture over and over and over again, but it will only keep the last 3. So if we're worried about a disk space issue as far as how much data we're going to collect, that's one benefit of using this ring buffer right here. We could also set up a stop capture based on after so many packets or after so many megabytes or after so much time has gone by with this option right here. I'd also like to have you take a look at that multiple files folder, which is right here. Wireshark captures multiple files. There's no files there. What we would expect to happen is after we start this capture, once we get at least 3 capture files, that's the maximum that would be in the file system. The new ones would be placed in and the old ones would be taken out, again, for the purpose of not burning up too much hard disk space. So let's go ahead and we'll start this capture. And there we have it. So because we set it for 30 seconds, if we go down here, we have the default profile running, which is fine. And I'm going to scroll these on the status bar all the way to the far right so we can see the detail here. And if you'll notice right here, it says multiple 00001. Now once we hit that 30-second mark, it's going to, or the 10 meg, whichever comes first, is going to convert over. It just did. So now it's on multiple 0002. If we want to generate some traffic and help that along its way, we can certainly do that. Let's go ahead and open up a browser, and let's go to YouTube. We'll go to Keith6783 real quick. And let's go ahead and play a video. All right, so now that's playing. We'll go ahead and put that, minimize that in the background. So currently we're on capture number 3, file number 3. And once we hit the limits, either the time limit or the size limit, so what we would expect to see in the file system, let me bring that over live real quick, is in the file system, we're only going to keep the last 3. So when this goes to multiple 00005, it will also delete 00002 because we said that we want to only keep the last three. And there we have it. So because I don't have any automatic stops in place, let's go ahead and manually stop this by using our icon on the toolbar. And now we've got the last three files. So if we wanted to open up, for example, multiple 00005, we can now go through that and analyze the details inside of this capture. If we wanted to change the profile, we could simply click on the profile in the toolbar or go to Edit and Configuration Profiles. Choose the profile we want to use, click OK. And then we have the benefit of using whatever profile we want to best view this data. So we could go ahead and scroll down through this, take a look, and look at this. We have a whole boatload of duplicate acknowledgments that Wireshark is reporting inside of this capture file. I'll put these three captures, by the way, 003, 4, and 5, all up in the Nugget Lab area, so you'll have access to them if you want to go through it. If this was a production network, I would absolutely want to dig in deeper and find out what the heck is going on. Is this normal as far as what normally should happen or does happen? And if it is, I would want to find out why these duplications are occurring. And we'll save some of that troubleshooting for another video together. Another cool video that we're going to make time for in a separate video is using remote interfaces. If we have Wireshark, we don't have to record just what's coming in our local interfaces. We can have Wireshark reach out across the network to another device who is capturing data and collect data remotely from that device. We'll also have a separate video just on setting up capture filters to control what makes it into the capture when Wireshark is currently capturing data. In this video, we've identified some options regarding location, where we're going to capture the data. If this computer right here is having the problem, it's a good idea to capture data when we're analyzing that problem as close to this device as possible, which would include a tap right here, running capture software on the computer itself, using mirroring of the port with the span that we did in the demonstration, or some other option that gives us the capture of the data really close to where it's occurring. We also took a look at options for collecting data inside of Wireshark, specifically what interfaces we can choose from and the type of files that we want to create. What's the maximum size of those files? Do we want to use multiple files? And what should trigger the creation of a new file? Is it the size of the file, or is it how many seconds or minutes or hours or days have gone by? We can set up all of those options inside of Wireshark. Regarding filters, we can control what Wireshark will include in its analysis, in its capture, by setting up a capture filter, and that is such a big topic, we're going to put it in its own nugget all by itself. Your homework assignment is really simple. Two basic things. Number one, I want you to continue practicing with Wireshark. Now, if you're locally running it on your computer and you can capture it there, that's great. If you have another option of one of these three, I'd like you to try that as well. If you have an option of using a tap, like this one or a more fancy one, if that's available to you, I would recommend trying it out and practicing with it. If you have a switch that supports port mirroring and you're allowed to make those configuration changes to that switch, I would recommend you try that as well. If you have other software or systems in your network that are capturing data, IP packets on a network, you may want to try to open that file with Wireshark. You'll be pleasantly surprised at how flexible Wireshark is about opening other products' capture files. I've had a great time. I'm glad you've joined me. I hope this has been informative for you, and I'd like to thank you for viewing.